Today's update is both focused and specific. We have one newly captured image of 3I Atlas, a confirmed result from our radio analysis, and a collection of unrelated yet significant space images taken today. We will examine each of these carefully, beginning with the sole new 3 Atlas image obtained in the last 24 hours. This is the only new 3I Atlas image taken today, captured on December 22, 2025, from Italy using a 25 cm Newtonian telescope. The alignment is based on the stars, not the object itself, which is why you see two tracks. The shorter, diffuse track represents 3I Atlas, moving relative to the background stars. Conversely, the long, perfectly straight line slicing across the frame is an artificial Earth satellite. This differentiation is crucial. The geometry, brightness, and alignment clearly indicate which track is natural and which is not. There was no enhancement or interpretation involved. This is simply a straightforward observational frame. In addition to the new images, there's a significant update related to the radio search focused on 3I Atlas. This marks the first time dedicated radio analysis has been conducted on this object using the Allen Telescope Array. The objective was both straightforward and precise, to search for narrowband radio signals that can't be generated by natural astrophysical processes, making them easily distinguishable from background noise. The observations spanned frequencies from 1 to 9 GHz within a concentrated time frame shortly after the object's discovery. This scan yielded an extensive dataset featuring more than 74 million initial detections. Although that figure may sound alarming, it's entirely typical. The majority of these signals originated from Earth satellites, aircraft, ground-based transmitters, and instrument noise. Thus, the team employed a rigorous multi-stage filtering process. Initially, they eliminated pre-known interference-prone frequency bands. Next, they filtered signals based on their frequency drift, which aligned with the specific motion of 3I Atlas. Lastly, they compared the on-target and off-target beams to rule out local sources. Ultimately, only 211 signals remained. At this stage, these were not detections but rather candidates for manual analysis. Each one was examined one by one. The outcome: all 211 were definitively classified as radio frequency interference, mainly from satellites or local terrestrial origins. No signals were found that could be attributed to 3I Atlas. This non-detection remains scientifically significant, as it enables researchers to establish the strongest upper limits thus far concerning any potential radio transmitter linked to an interstellar object. If 3I Atlas is indeed transmitting, it is quieter than current instruments can detect. This isn't a failure, it's an example of how meticulous science operates. This image was captured on December 22nd, during the winter solstice, from cruising altitude over Greenland. What you see isn't an extended exposure from the ground, but rather an auroral arc viewed from within a commercial aircraft through a window at approximately 35,000 feet. The green luminescence results from charged particles colliding with oxygen atoms high in Earth's upper atmosphere, generally around 100 kilometers above sea level. From this viewpoint, the structure appears flatter and more layered than from the ground. Additionally, there's a subtle hint of pink at the edges, which typically indicates high-energy interactions involving nitrogen at greater altitudes. This perspective is important. It illustrates how extensive and vertically deep the aurora truly is, reaching far above the clouds and extending well beyond what ground-based photographs can capture. The same physics, but viewed from a different angle. This image is not optical, it's thermal. What you are seeing is data from a SAT-TV Earth observation satellite, measuring heat in the long-wave infrared spectrum. The bright orange and red areas signify unusually high thermal output, which is not related to weather or sunlight. This facility is one of the largest cryptocurrency mining centers in the United States. The labeled areas indicate concentrated heat signatures emanating from rows of mining hardware located in nearby electrical substations. The heat generated is sufficiently strong to stand out sharply against the surrounding infrastructure. This is not a simulation. It's a direct satellite measurement of energy loss. What makes this significant is the scale. These systems convert electrical energy into computation, and nearly all that energy ultimately turns into waste heat detectable from orbit. This inefficiency becomes visible, serving as a reminder that modern digital infrastructure leaves physical traces, even when designed to be abstract and invisible. As thermal satellites grow increasingly sensitive, these kinds of industrial heat signatures become harder to conceal. This is a star cluster known as Westerland 2, captured via the James Webb Space Telescope. What you are observing is a stellar nursery, a dense area where hundreds of young stars are forming within thick clouds of gas and dust. The bright white points are stars in various stages of their life cycles. Some are massive and already influencing their while others are smaller, dimmer, and just beginning to ignite. For the first time, this dataset reveals the complete population of brown dwarfs within this cluster objects that are too large to be classified as planets, yet too small to maintain fusion like true stars. This is significant, as brown dwarfs inform us about how effectively nature converts gas into stars and planets within extreme environments. The red and orange clouds showcase gas that is being sculpted and pushed outward by radiation and stellar winds. The blue glow arises from hot, energetic stars illuminating the area from within. Nothing in this scene is static. Every filament and cavity is molded by feedback from newly formed stars. This is what stellar birth looks like when you zoom in, completely messy, crowded, and tremendously productive. It serves as a reminder that even in the most chaotic regions of space, creation remains the dominant process. That brings us to the conclusion of today's update. We've explored new images of 3I Atlas, fresh radio results, and captured snapshots of how active and dynamic our local universe is. From interstellar visitors to auroras and regions of star formation, what are your thoughts on today's updates? Has any of this changed your perspective on 3I Atlas? If you'd like me to continue tracking new 3 Atlas images as they arrive and analyze them frame by frame, let me know in the comments. If you find this type of clear, evidence-based space analysis beneficial, please like, subscribe, and share this with someone following the 3I Atlas story. More data is on the way, and we'll continue to follow it, one image at a time.